Good afternoon, everyone. My name is Mir Zahir Abbas. I am the Operations Manager of SISEC. Welcome to today's webinar. The regular ground rules. All the attendees to the webinar will be on mute by default. We will have a Q&A at the end of the presentation. You can type your question on the chat window and it will be responded after the completion of the presentation. We are also going to record this webinar and the recording will be uploaded on the SISEC YouTube channel, so you can always refer back to the video later if necessary. This webinar is part of weekly series titled Samgacchadhwam, May We All Progress Together. The objective is to cover different topics of security over the course of this series. We want to provide a conceptual overview in these webinars to the various aspects of security and hope this will kindle your interest to explore further. This is the 16th webinar in this series. The topic of today's webinar is Malware Trends and Analysis. We have 3 more interesting webinars by McAfee in next few weeks. We will open the registration for the next week's webinar shortly, and I hope you will find this series of webinars useful. Do let us know if you have any feedback as well as any ideas to share with us. As usual, we will have an assessment made available at the end of the webinar. The assessment will be kept open for 60 minutes after the completion of the webinar. The questions are from the topic covered during the webinar, so you should not have much difficulty in cracking this assessment. Those who get 7 or more correct answers out of 10 questions will be provided the certificate of achievement. At the end of assessment, you will also be asked to provide feedback on the webinar. Please provide your genuine feedback and rest assured the feedback will not have bearing on the assessment. You need to have a Gmail ID to take this assessment. Please make sure you provide your details accurately while taking the assessment, because the certificate will be generated based on the details provided by you. The link for the assessment will be shared at the end of the webinar in the Q&A section. Also note that the assessment is open only to those who have participated in the webinar. Those who successfully complete the assessment will be provided a certificate of achievement, and those who have attended the webinar but could not take the assessment will also be provided a certificate of participation. Let me now introduce the speakers for today's webinar. We have 3 experts from McAfee speaking in today's webinar. Senthil Chidambaran is a director, software engineering at McAfee. Senthil has more than 19 years of security domain experience. Currently, Senthil manages the teams responsible for the testing, quality assurance, and release of different McAfee content streams. We also have Deepak Sethi, who is Security Research Manager at McAfee. Deepak has 15 plus years of experience in security domain. He currently manages teams which are responsible for authoring AV content, whitelisting applications, and providing threat mitigation. The third speaker we have today is Sriram P., Security Research Manager at McAfee. Sriram has more than 15 years of experience in security domain and is currently responsible for research and content authoring. Now I'll hand over to Senthil to take you through the next part of the webinar. Over to you, Senthil.
Thank you, Abbas. I'll just share the screen. Is my screen visible?
It's visible, boss.
Okay. Thanks, Abbas. Good evening, all. Welcome to the webinar from McAfee on the topic Malware Trends and Analysis. I'm Sendil, and I'm a Director Software Engineering at McAfee. So this is going to be the first of a series of 4 webinars that we are going to present from McAfee. And the topics have been aligned in a way that will help you start from the basics and then move towards the various solutions and the various technologies that are present currently in the malware industry. So today's topic is malware trends and analysis. And in today's agenda, we have the following topics. We start with a little bit introduction to malware. How did the malware evolve? What are the different types of malware? Where we would be covering how different types propagate, spread, and also create havoc in the endpoints. Then we will move on to talk a little bit about the threat landscape, which is nothing but what is currently prevalent in the malware field. So we based on what we see as part of our work in McAfee, we have different data points to help you understand what is the current threat landscape, what are the types of malware that are currently creating problems, and a little introduction to them. As part of threat landscape, we will also be diving in little deep into 2 topics, which is one is ransomware, and then we'll also talk a little bit more on Linux malware. So we have all been familiar with Windows, but since Linux malware is also important and they are becoming more prominent in the current world, there's a separate slides on Linux malware. So once we do this, we get into a next topic, which would be reverse engineering, which is nothing but the ways in which you can reverse a file to identify if it is a good or a bad file. So this is basically what the researchers do in the organization to identify a malware. So Sriram would be talking about the ways in which you do reverse engineering. It could be both static and dynamic reverse engineering. We cover what it means, what are the different tools that we normally use for reverse engineering, and some examples of how you can get started with reverse engineering. We also have a small demo at the end to show you how dynamic analysis is normally done. And then we'll end with a question and answer session. This is going to be a introduction to malware and introduction to the next topics which would be covered from McAfee during the subsequent weeks. So understanding what we talk now will go a great way in helping you get prepared for the subsequent sessions, which would be hosted by McAfee in the coming weeks. So with that introduction, we'll move to evolution of malware. At this point of time, I would like to invite Deepak, who is a research manager with McAfee, and he's a subject matter expert in malware analysis. And so I invite Deepak to take it forward. Deepak.
Thanks, Sendil. Hi, guys. So my name is Deepak, and I will be talking about evolution of malware initially and go through the complete cycle of explaining you different types of malwares, which are pretty famous today. So in recent news, you guys would have heard the Australian government giving out advisory. This is in the last 2 weeks that nation-state actors have been attacking their country, the government resources, and last week even CERT India gave out that advisory that there would be a lot of spam-based attacks on the government organization. All these are nations hiring people with knowledge about the systems, people know how to crack the system, or as we call hackers, to attack other nation states and causing harm to their infrastructure. This is where we are today. I will just take you back when all these started. During that era, it was very humble. The way it started was very humble. It was not for harm. It was to understand information. 1971, when the first, at least according to the computer historians, when the first malware worm was written, it was called the cheaper worm. It was written by a scientist called Bob Thomas. What Bob did was they had these mainframe machines in ARPA. ARPA, by the way, stands for Advanced Research Program Agency. Most of the innovations related to computers comes from ARPA. So what Bob Thomas did was he wanted to send information between mainframe computers. These are the DC mainframe computers at that era. To see how messages can be sent over the network. And in 1975, with the advent of personal computers, computers were no longer used only for solving solving problems. In 1936, if you realize that Alan Turing made a machine to crack the Enigma code which the Nazis used, since then computers have evolved, and from computing alone, it started being used in others for personal use, like entertainment as well, for sending out emails. So in 1971, after Creeper Worm, in 81, Ian Murphy, or Captain Zap, as you see it, he hacked into AT&T's network. And during those times, AT&T had different call rates in the night and the morning. So what he did was he just changed the clock, and so the consumers using this were getting different call rates. So he was convicted. That was one of the first convictions. So after 1975, when the personal computers was introduced, 1981, you saw the first conviction. And the malware writers or the hackers went on after that. And in 86, the American Congress made hacking as a crime, and they were convicted for hacking into or illegally entering into another computer. It was still the era where people did it for curiosity. The Morris worm, if you see, 1988, was one of the most famous worms which was introduced. This was done by Rob Morris. He was part of MIT then. What he did was this was written just to exploit vulnerabilities in the machines connected. These are still the Unix machines, and his worm, what it did, unknowingly, he wrote it to exploit vulnerabilities, but it spread to more than 6,000 machines, and it became like a DOS attack, and most of the machines in that network crashed. This was still in the ARPA. During that time, some of the major universities in ARPA were connected. After this era, when internet became pretty famous, 1999 was when the Melissa worm came out. So Melissa was one of the macro worms which came out. So it basically was a macro program written in Word. So it used to come as an attachment, and when you open the Word attachment, it used to look up at 5 contacts in your Outlook, and then it used to send out a mail to everyone. So there came an era, this comes an era where people tried to hack to show that I'm better than you. There was a worm called I Love You, which came out, and the main concept of the worm was to destroy the files. It never stole information. All it did was destroy the files. So this is when, the hackers started saying that we are better than you. And everyone would have heard about the famous Anonymous group. They were formed in 2003. So one of their main errors were to hack the government organizations, get data, and publish it in the open domain. North Korea was one of the first countries which were caught for doing espionage by training hackers and sending them to South Korea and Japan. So one of the major hacks which you could find from the North Korean hackers was the Sony pictures, where they hacked into Sony pictures and released the unreleased pictures. So this was in retaliation of the movie which Sony made based on the North Korean chairman. Since then, the attacks have been becoming more sophisticated. Later, in 2016, ransomwares were used to attack healthcare sectors, where the data of was encrypted. Data which was stored in the healthcare database was encrypted, and ransom was asked from users in order to release it. I will speak more about ransomware later in the presentation. And in 2017 was one of the major attacks which happened, two major attacks that year actually. WannaCry, which most of you have heard about, it used the Eternal Blue exploit. So Eternal Blue was one of the exploits which was released by one of the hacking community. It was used by NSA. So they hacked NSA and put this Eternal Blue tool outside for everyone to use. And WannaCry used this Eternal Blue, and within hours of starting the infection, it spread to lakhs of computers around the world. Later, 2017, there was the biggest hack. It's probably the biggest hack of the century so far. Equifax, which held data of more than of a lot of American consumers. 500 million data of 500 million users was released to the public. The data included social security numbers, the passport numbers, and even license numbers of some of the users. They were all released in the dark web. So as you see, as our connections are increasing, the hacks have become more and more sophisticated. And as you know now, from a coffee machine to a supercomputer is connected. So the sophistication of hacks have increased over the years, and it is going to increase. It is going to get more sophisticated. With this, I will talk to you about a little bit about different types of malwares we have today in the market. So what is malware? That's the fundamental question everyone asks. So any software which is written for a malicious intent is a malware. And how do you say it's a malware? It's by its purpose. What does it do? One of the main things a malware does is to harm a computer. Things like slowing it down, making it unusable, and even stealing information like your passwords and then sending it out to another machine. So how does it do it? So malware, every software has a trait. The trait which it identifies, by which we identify it's a malware. Santal, can you move to the next slide, please? Yeah. So these are some of the main traits of a malware. So as I told in the previous slide, I said it steals information from your computer. How does it do it? It steals information from your computer by recording keystrokes. That's one of the things which it does. And these are some of the common functionalities of malwares. It injects code into programs, it downloads other files, and it tries to spread from one machine to another. So with this, let me talk about the different type of malwares we have. These are the main malwares, and there are a lot of subcategories which I wouldn't go into right now. Some of the main things are worm, Trojan horses, droppers, virus, and rootkits. I will talk to you a little bit more about virus, since everyone is talking about virus these days. Yeah, the computer virus, definitely not as complicated as the human virus, but it is one of the most complicated malwares in the computer world as well. So computer virus, like the human virus, does not work independently. It needs another file. So it infects another file and then it moves. So it cannot run independently again. So I will explain to you four different types of computer viruses. One is appender, propender, overwriting, and cavity. Let's get to appender. So this is basically how a typical file looks. Sriram in the later part of the presentation will explain to you the different, will show you a file and tell you how exactly it looks, but this is the high level view of it. This typically is a PE file. What appender does is it gets into the PE file and then it adds a section of a separate code at the end of the file. Like it appends the code. That's why it named as appender. And what it does next, so for a file to run, there is in the header of the file, if you skip 3C bytes, you find the address. The address would point to something called the entry point. This entry point is from where the file starts executing. So the malware, what it does is it changes the header and changes the address in the header to point to its code. How a virus runs is it needs to get control. So once it gets control of it changes the header, it stores the address, the original address, and keeps it in its virus code. Then once the control goes to the virus code, it does what it has to do, infect other files or whatever it has to do, send information to another server, and then it jumps to the actual entry point. So in the cleaning perspective, like what our antivirus does is we need to understand where the virus stores the address, and then we take the address and patch it back to the original entry point and remove this code. So this is how antivirus cleans the virus, but this is typically how Appender works. The complexity of virus depends on how encrypts and saves the original entry point of the file. This is typically how Appender works. Propender would be exactly the same, but it just adds the virus code at the top of the file rather than at the bottom. And this is destructive one. This is what I was telling you during the Evolution I Love You virus, which came out in the 90s. All it does is it overwrites the file. So it does not care if the file does its own work. It comes into the machine, it writes its code over the file's code. And the file basically does not do its actual duties. All it does is run the virus code. So next thing comes the cavity virus. This is a very interesting type of virus. What it does is it uses the cavity in the file, that is the zeros which are used in the file, and writes its own code. So typically what it does is it does not change the entry point. All it does is it adds, it changes one of the instruction after the entry point, and then it jumps to the other block of virus. So the virus is not present at one point in the file. It is distributed as blocks throughout the file. So in this case, what I was trying to say is after the entry point, when the file starts running, one of the instructions is changed to point to the virus code, which then jumps to the main virus body, and then it does its work and then jumps back one instruction after the jump instruction, and then the normal execution of the file starts. Why this is more, why something like this is used? Because cavity viruses take very less space. Like in an appender or a prepender, the whole virus code is added at the end. But in a cavity, it uses the empty spaces in the virus itself to add itself. So the main size of the file does not alter too much. So yeah, this is where then we come to worms. Worms are software which self-replicate. You would have heard about the most famous one of is the INF files which use an USB. So one of the main things how it spreads is it can spread through a network, it can spread through a USB drive or a shared drive. The unique part of worm is this was one of the first malwares which even went to space. So one of the astronauts actually carried a drive with the worm, and it spread to space as well. After worms, let's go to Trojan horse. Trojan horse is like the story of the Romans and the Romans. So this how this works is you download a software from the net, and this file is embedded in it, and it comes into your machine, and it opens up a backdoor for other malwares to come in. It can do other things as well, like disabling the security software, stealing information. So the name of Trojan horse comes from Troy. Okay, let's go to the next one, Sandra. Okay. Backdoor. Backdoor downloaders and groupware. These are different types of malware. Backdoor, what it does is once it comes to the machine, it opens up a port which allows other softwares to connect. It's typically like how any of your remote admin tool works, just that it does not need a password. So if you, like a team viewer or something, you install on your machine and then give access to your friend by giving the username password, and then he can connect to your machine and do whatever he wants to. This is done illegally. That's the only difference between a backdoor and a software like that. A downloader typically comes into your machine and its main functionality is to download other malwares onto the machine. Rogueware, I will talk about rogueware later in the ransomware chart. It is basically like a fake alert tool. Okay. Keyloggers are softwares which logs the keystrokes in the machine. So this, there are some commercially available keyloggers which you can install on the machine, but mostly the malwares use them to log your keystrokes without knowledge of the user. Adwares are programs which monitor your browsing techniques, and based on your browsing techniques, it displays ads. Adware companies used to make a lot of money initially. So there was a company called Gator, was one of the first malwares. They used to come into your machine. So they were used to save passwords initially. So the main, so you could install a Gator wallet, and what it used to do is save all the passwords of different sites you go. And then what it used to do is monitor your browsing habits and show ads. At a point of time, they were so prominent that, say you're looking at books on a particular website, it would show up an ad from another website at a cheaper rate than what you're looking at. So this is typically how adware works, and McAfee calls it as PUP, potentially unwanted programs, and then that's how we detect adware. Okay, with this, let me talk to you about the threat landscape of today, how the landscape looks, and what are the major malwares we have. In McAfee, we have over a billion files, and we monitor which of these families are prominent at a particular point of time. In this is the latest data we have. So here you can see these are some of the families we monitor: ransomwares, miners, office malwares, and PowerShell-based malwares. So ransomwares, I will talk to you in the next slide. I have an entire chart on the evolution of ransomwares. What are miners? Miners are a unique piece of malware. This mainly started in 2018, at the end of 2018 to be exact. And it's increased 2020, and now the numbers are pretty high. What are the miner? So what miner does is it comes onto your machine. It uses the machine's resources to mine for a Bitcoin or any cryptocurrency. Bitcoin is not used anymore because, of course, Bitcoin needs a specialized hardware. What typically the miners we see now are mined for Monero, because Monero uses something. There was something called the kryptonite algorithm which was used, and this kryptonite algorithm works on the normal machines which we have. And another advantage of Monero is untraceable. Bitcoin, the transaction you make are pretty much traceable, but Monero, it's not. So Monero is very famous, and most of the malwares these days mine Monero. Let me come to PowerShell. PowerShell, these are the non-PE malwares. So we moved from PE, which is the portable executable, the exe and DLL which you found, to non-PE. We have a lot of Word malwares, which you can see below the Office malwares, and we have a lot of PowerShell malwares. So the Trojans or the worms nowadays, they don't work individually; they work in tandem. Like there is as you see, the trick bot, which I mentioned in the Office malware, it downloads onto your machine, and then it downloads. It comes through attachment as Word attachment. It then runs the macro, and the macro either downloads either downloads a ransomware or it downloads a password stealer onto your machine. So all these things do not work individually. They come as an attack, and I'll explain to you more how it works in the ransomware evolution chart. Okay. Can we go to the next slide, sir? Yeah. There is another chart completely on the Linux malware, the ELF part. Sriram will explain to you how the Mirai botnet works, and Mirai botnet works, and PDFs. PDFs are something which malware is used a lot before, but it was on a decline. And in 2020, we have seen a lot of PDFs. These PDFs are mainly used for spams. So it's spammed out, and they have links to which downloads other malwares. And yeah, with this, let me start the ransomware revolution. Okay, so this is the entire story of ransomware. Ransomware started as fake alerts, the rogue software which I talked about during the malware types. Initially, what it used to do is it shows out when you download the software on your machine, it used to show errors saying that your machine is infected with 10 viruses, 5 viruses and stuff. And then when you say clean it, it used to ask you money in order to just show up these messages. Then came an era where these malwares used to lock the screen. It used to just lock the screen and used to tell you to buy Ucash vouchers, where you can just had to buy the voucher, put the number in an email and send it to them, and they used to send you the password to put in and then unlock the screen. So people, many of realized that they started making a lot of money using this, and then they started getting more sophisticated. CryptoWall was one of the first ransomwares which started using symmetric algorithms to lock the files, to encrypt the files. So it used a tiny algorithm, which was not very complicated. So it used to come on the machine, encrypt each file with the algorithm, and it used to throw up a message showing that your file's encrypted, pay us so much, and then we would send you the key. The thing about symmetric algorithms is both the encryption and decryption uses the same key. So if we reverse the file, we could find out the key, and we could actually give the files back to the customers. We had detections and cleaning for most of these crypto initial versions of malware which used the symmetric algorithms. Then what happened is then they moved from symmetric algorithms to asymmetric algorithms. Asymmetric algorithms is the encryption which is used these days, where there is a public key and a private key. A message is encrypted using the public key, and then a private key is used. Only that private key can decrypt that message. So these are pretty complicated, and decrypting something like this is not at all easy. So this was the techniques they used, and the payment mechanism as well changed. So after the asymmetric algorithms, they made the changes in the way they ask for payment as well. So CTB locker, which stands for curve algorithm, Tor browser, and Bitcoin. So they were one of them which used the elliptical curve algorithm for encrypting the files, and they used Tor browser to communicate. Tor browsers are basically the browsers where you browse onion sites, where the deep web sites, and then it asked for Bitcoin as ransom. It did not take the Ucash vouchers anymore, and they started using Bitcoins for taking ransom. This evolved slowly, and from there, Abdopol was one of the first malwares which started using PowerShell as a non-P way of encrypting files. What it did is it downloaded the files. It did not drop it on the disk. It used reflective loading to load the file directly into memory and then encrypt the files. So this was the evolution since then. And after that, there came out a model called RAS. Have you heard about software as a service? Ransomware started this as well. It's called ransom as a service. What they did is you just need to become a part of the group. You get the affiliate ID, and you don't need to design the ransomwares anymore. All you need to do is spread it. So the more you spread, the more money you make. So this was the model that started, and it's been very active since then. There are a lot of ransomware families which work this way, like Riot ransomware, which you see, which is pretty evident since 2018. It's even very strong today. How it works is there is a Trojan called Emotate, which does not encrypt. What it does is gets into the machine, then downloads this ransomware onto the machine only if it feels the machine is viable. That means it's not a single machine, but it's connected to a lot of machines. So all these things work in tandem. They do not work alone. Today's evolution is in Q2 2020, what we found is one of the ransomwares were Snake. Snake ransomware, the reason I'm mentioning Snake is it does not use traditional ways it's not coded in the traditional way. It uses Google's Go language. So decrypting or disassembling something using Go language is pretty difficult. So Snake uses that. And other major ransomwares is Sorino-Kibi. This was involved in the Texas attack, where Sorino-Kibi was used to infect the Texas power plants, and it was down for a long time because of Sorino-Kibi. Ransomwares also did something like infecting the MBR itself. So rootkits were used along with ransomware to infect the file the file system. They not only infected the file, what they did is they also encrypted the file system, so the user couldn't even log into Windows. As soon as you switch on the machine, the MBR transfer controls to the rootkit code, which then would display the screen saying that you've been hacked and you need to pay so much to go further. So this is the evolution of ransomware, and it is one of the major families, malware families, and major families today. So with this, I would invite Sriram. Sriram will be talking about Linux malware, and then he would also be talking about reverse engineering. Over to you, Sriram.
Thanks, Deepak. That was a great talk. Thanks for that. Thanks for the good introduction. So let me start with Linux malware evolution. Like how you saw ransomware getting evolved. Linux is not so very much evolved because you don't see much of threat families or the kind of groups there. But there is few notable ones like the Gap kit, which we started seeing in 2016, and Mirai, which was around Q3 of 2016. Predominantly, what they do is they just search for any of the open SSH machines, and then if it is found vulnerable, like using default passwords like admin or admin123 or admin password or those kind of password, they just log in. And like how there is a fileless malware version, we also have a fileless version of Mirai here, where all it does is just directly goes into the machine's memory, and it keeps executing the malware code. You won't be able to find it in the system or in the IoT device, and all you need, and even if you reboot, it is gone. The system is clean now, so it's really stealth, and it's really efficient. What happened was in the year of 2017, the source code for Mirai got exposed, and from then we started seeing a lot of other malware like IoT Reaper, WinNTI, and other Ecorax, which is again a DDoS botnet based on this. The reason why we are seeing more amount of IoT based malware is because it's completely stealth, and there is not much of AV tools available currently in the Linux space, and DDoS is something which IoT device can happily do because they don't have much CPU functions. They don't have heavy CPU capabilities like encrypting a file or encrypting a stream or encrypting a file system, because the CPU is very small, but their network activity is really efficient. If 10 IoT machines can go and DDoS an Amazon AWS service, which happened in 2018, was one of the biggest attacks in that example. So the way they can infect or they can affect a network device is really good, and that's the reason why it is evolving as a botnet, and we do still see their activity, which is really high. So it is something which is a threat to look out for in 2020 and 21 going forward. So coming to the next slide, I'll just explain how this Mirai, what I just explained, how it works. So what it does is from an attacker machine, what he does is he uses utilities like Shodan or any other open source utilities to scan the whole network around for the thing, for any open source or open any port or anything. So what happens is, if it sees any vulnerable public-facing application, then it downloads Mirai sample of whatever architecture it is. Like if it is from an ARM architecture, it will download a binary which is compiled for the ARM architecture. If it is a Spark or MIPS based one, it downloads them accordingly, because it is executed via a script, and like how we have bash for a normal script interpreter, most of these commands are good enough to identify what architecture is running on, and then it downloads the specific binary accordingly. And malware authors are so sophisticated that they have even compilers for ARC and Motorola kind of hardware, which is really shows that they are really capable of infecting any kind of hardware devices which run Linux on it. So that's which on IoT, and it's IoT. So once it executes it, it communicates back to the CMC asking if it has any control command to do. If it says go and scan for some other ports in some specific IP address, it does that. Otherwise, if it says, yeah, collectively go and DDoS a specific IP address, it searches an attack on a specific port like 480 or 443 or any other similar attack which it's been asked for. So thus it joins the botnet and it performs, basically Mirai is designed for network DNS service. So all it does is it has good efficient DDoS code, and it works perfectly until that point. So that's how Mirai works. The next slide, please. So from this Linux evolution, I'll jump into reverse engineering, which is a kind of a widely known topic which a lot of colleges have started talking nowadays, and it's really good to see people doing reverse engineering, and it's really promising for people, a person like me who likes doing reverse engineering. So the first thing which I would like to start for learning malware reverse engineering is this quote from Stephen McCain. So it says, the master has failed more times than the beginner has even tried. So basically what I wanted to explain here is, or what I want to put my point forward here is, the more amount of practice, the more amount of probability you keep trying and trying, that is still not enough for any reverse engineering. Reverse engineering is an art. I would say reverse engineering is an art which you, or a skill which you can't acquire by just reading a book or just observing to some seminars or something. It's something which you need to keep trying and trying, and reverse engineering is something which you need to do a lot of tries. You need to keep trying it again and again to find out what function it does. Every time I open a file for dynamic analysis or static analysis, I do get something new for the specific file, even if it is a file which I've seen like more than 15 years ago, or when I was doing my college days or any other time. I still see the file as new, and it really keeps me to work more. So you need to do a lot of practice to understand reverse engineering and to master the art of reverse engineering. So that's the reason why I put this quote here. So if you ask a question, why reverse engineering? So maybe I would say, I want to understand how the thing works. Like, for example, if I buy a mobile, I would want to know how it works. So first of all, what I'll go and see is what is its configuration. So normally it's found in settings. So you need to go to the settings and find out what is the CPU type, how much RAM it has, what is the GPU memory it has, what is the CPU it has, all those kind of things. So what happens is, this will help me to get a deeper understanding of what kind of an architecture which I'm working with. And then I can go further a step saying that if I click on a button, like for example, if I click on a submit button on a website, what will happen in the backend? Each and every step, the flow of packets, everything is something which I wanted to go for or understand. That is the point when I would start understanding or reading about reverse engineering. And for me, I like reverse engineering, and I'm I'm very passionate about it. So I would want to do it for fun of it. For example, if there's a developer who says, yes, I have created a calculator application, I would go and reverse engineering and say that there is a vulnerability in this, there's a buffer overflow on this. I would like to do that. And that's the reason why I say it's reverse engineering and I do it for the fun of it. So that's it. So for performing all these actions like reverse engineering, whatever steps you see in reverse engineering, you need tools for it. So you need to use the right tools. And using those tools, it makes you human. And with tools, you won't be able to do anything. So you need to use the right tool to do the right thing. And that's why I wanted to highlight this quote from Thomas Carlyle saying that human is a tool using animal, and without tools, he's nothing. And with tools, he's one of the he can achieve wonders. And with tools, he's all. And I like this quote from Thomas Carlyle. So the combination of right tool with the right amount of practice helps you master reverse engineering. So you need to put that in your mind. So to start with, I'll just try to give an overview of what all the tools which will be easier for you to understand the tools of the trade. I'm not going to do deeper into any one of these steps. These are just for names which you can remember, so that in future, if you can come back and if there is any kind of specific file type you want to reverse, you can open these tools and try to look at it. So to start with, for Windows debugging, you can go for Oily Debugger or Immuno Debugger and IDA Pro. The best tool would be WinDBG, but it has its own advantages and disadvantages. But a very beginner to start with, you can use Oily Debugger. The second is with hex editors. Hexedit with Q32. That is one of the best tools for binary viewing of a file. And then for JS and VBS debugging, Visual Studio IDE is the best. For Android Studio and X2Jar are a very good tool. Similarly, for Linux, GDB and PE disassemblers, it's IDA Pro and Dadare with GHydra. GHydra is a very good tool. If you really understand it, it's a fantastic tool which was used for reversing it was used by or created by the NSA. So it's really good and it's really deep rooted. So other normal simple tools which you can do for top level EID for finding what kind of a file exe has been compiled, like if it is compiled from binary in Visual Studio, or if it is compiled in Golang C, or if it is Pascal, or if it is .NET compiled or VB, you can use PID. And then import reconstructor for unpacking a file and reconstructing the imports. Regshot for dynamic analysis. Process hacker to understand what happened between a process, what kind of a PE file, what kind of a resource it has, what kind of icons it has, all those kind of things can be done with process hacker. Autoruns to delete or undo any malware activity. Rohitab's API monitor is one of the best, which has been released maybe from 2002. It's a really old tool, but it's still really the best one for API monitoring. And volatility, which is again a Python-based one. So for a master in Python, you can go with volatility. That's a very good one. And then TCP view. TCP view is again a very good one for Windows-based network analysis. For Linux, you can still use the TCP view. It's still good. Wireshark you can use for both Windows and Linux. Yara is for file comparisons, binary views, and then string search or very heavy duty searches. You can use Yara, which is again based out of Python, and its regular expressions are really good. And then File Manager for again binary viewing, and Total Commander again for a good UI, a good look and feel. If you don't want to double click a file from Explorer, you can use File Manager or Total Commander to browse through your folders to have a binary view of the NTFS stream. If it has alternate streams, you can read it. All those tools, Far and Total Commander can be used. So that's the overview of the tools. I'll request you to go and search on Google for all these tools and try to understand what they really do. So for reverse engineering, to understand reverse engineering, I'll just start with a simple goal, which is like step one. So what I've done is I've just written a Hello World program on Visual Studio Express Edition, and then I just compile it. So what I do is I just wrote a return main, which is for your white format and the Hello World. So like how previously Deepak said, it's about the PE file format. Once you compile this C file, it will give me a exe file. So this snapshot below, which is in assembly, gives the settings of what kind of the high level language got converted into machine level language. So this screenshot, what you see is from Oily Debugger, and it converts that machine code, which Basically, you see like 4883EC28 on the memory location 1000, F0D1000, specific location. So in this memory location, this is the binary code which is available, and it's a stream of instructions, stream of binary mnemonics. It's called mnemonics. So you convert that binary word into an assembly code, which is sub RSC or whatever you call that. Whatever that specific instruction corresponds to, it disassembles and this OLE debugger shows you as an assembly code. And here in this example, you can see LEA, which is load effective address, to RCX register, that specific memory location for hello world, and then it calls a function called wprintf. And once the wprintf happens, it returns back saying hello world has been printed. So here temp underscore console is a exe name which I have compiled. So when I compiled this hello world, I named it as temp underscore console. So that's the reason why you get that string there. So that's with the coding part and then the disassembling part. This is very, very high level. What I want to do is I want you all you guys to write more amount of these kind of C programs and then reverse engineer it, basically put it on a debugger and see how the corresponding assembly code does. So the more you practice, the more you understand about how each and every instruction what you write in a C program gets converted into a machine understandable program and they get executed by the machine. So this is going to be the goal, and this is what I've shown you now. So to make it a bit more complicated, what happens is compiler has some set of options called compiler optimization. Basically what the developer has the flexibility from the compiler is he can compile the code for speed or for size or for optimization or without any optimization. So these are the kind of trade-offs what a compiler gives the flexibility to the user or the code or the programmer. So that's something which I'm going to cover now in my next slide. So if you can see the bottom image, that it says those are different kind of compilation parameters what my Visual Studio IDE gives it for you. So it can give you without any optimization maximum size or maximum speed or complete optimization, which is a trade-off between size and speed. So if you have a size, the performance of your instruction will go, of your application will go down. If you want speed, then size will be huge. So it's a trade-off actually, and that's the optimization what you see. So in the next slide, I'll be explaining about how the compilation works. So this hello world program, when you write, it goes through pre-process. I think this is out of a textbook. I'm just trying to give a quick overview of it, and it might not be the same how you see from a textbook. It varies with your textbook. So just a high-level understanding of it. So once it's a preprocessor, which processes your instructions or your C program for any syntactical errors, or if there's any what to say or if any instructions are written in a single line, it makes it into multiple line. All those kinds of things are done by the preprocessor. Then it compiles it, and then it compiles into an assembly understandable language. So for example, why you need that step? If you ask me, I would say that, for example, if I give you printf is a library function, and library has been loaded from stdio.h. So stdio.h is inherited from windows.h, and windows.h, if it compiles into kernel.dll. So basically, it needs kernel.dll from your machine to load this program and execute it. So at this point, what it will do is it will take the code which it has to call from kernel.dll. For that, it needs to set up few things previously, and all those things are getting loaded into the assembling instruction. So that's the reason why in the disassembly you see a call. So that call will make sure that what kind of call by value, or is it a call by reference, what printf is, and all those kind of things will be established. Then finally to link, and then finally to execute. So these are the sequence of instructions that we can see. So in the next slide, I'll be covering the compiler optimization. So what happens here is I'm giving you a bit more, one more line added to the existing code, where I'm not just printing hello world, but I'm printing it 255 times. So what I've done is I've just added a for loop saying for a starting from 0 to 255 and then incrementing it by 1, a plus plus. So if you see the right hand side, the top one in the blue screen, in the blue color background, which is the corresponding assembly instruction for it. What you can see here is from instruction number 4000106. In that location, you see move value of EBX, a value of FF. So FF, which is 255, which is hex 4 255, is moved to EBX register, and then the same instruction what you saw previously, the LEA gets which is the displaying of hello world, and the call which is responsible for it is being executed again. And then since the value of A, which is stored in EBX, it decrements it by 1, where you can see sub RBX, 1. So here I will compile it for optimize for speed. So you can see sub RBX, 1, and then jump on 0. So if after subtracting the RBX by 1, it asks for 75E instruction, where it checks if RBX register is non-zero. If it is not 0, it will still continue. Otherwise, the loop will still continue. Otherwise, it will exit the loop. So then what happens is the value is now FE. So again it compares. Again it compares for RBX, subtract and compare if it is less, and then it keeps looping. And that's the reason why you see 3 there, and it keeps looping again and again until it reaches a value 0. So the JNZ will fail and it exits. So this happens on this is how the optimization works. So you wrote a code which says you start from 0 to 255. But since the variable what you use is not referenced anywhere, compiler optimizes that variable to move from FF to 0, because comparing a value as 0, which is JNZ as an instruction, instead of comparing as equal to 100, for which it has to move the value 100 to a register or a location, and then it has to compare, and then it has to check if it is 0. So which includes 2 or 3 more instructions than the existing one. That is the reason why you see the compile optimization where it did 255 to 0, so that the instructions are lesser. So if you see the bottom example, you can see the similar call happening, but it checks, there's an instruction for JGE, like I said previously, comparison variable which it uses, and then it compares it with FF, and then if it is greater, then jump outside, otherwise loop again. So that is the option which you see below is compile optimized for for compile disabled option. So you need to when you do the reverse engineering of all these code, you need to understand what kind of a compilation this program has gone through, or your reverse engineering or your assembly code has gone through, and you will need to start putting your knowledge accordingly to understand what your original source code would be, which is your implement program. Next slide, please. So here in the next slide, I'll be covering the PE file format. In the PE file format, I'll be covering what is it's a very high level of what kind of stream which is being stored. So 4D5A, which is Malware, which is his example. You can see in the terms to be noted at point number 3, that's his example. He was one of the original architects of MS-DOS. So he has created MS-DOS actually. And that's the reason why we can see his name there. And then the location what we are interested in is location number 3C. This is from a tool called CFF Explorer. I'm sorry for that. CFF Explorer. So you can see that in the 3C location it says 0001 0000. You need to reinterpret this as a Little Indian format, Big Indian format, and then you will need to resolve it to 1000. So which is 4050450000, which is the starting of your PE address. So I'm not going to go full in detail into PE format, because there is a tutorial called ARTPE tutorial.chm. Just Google this and you will get a very extensive amount of the CHM files which has been written by this AR team, maybe from the early 90s or 2000s. It's really old, but it really explains how a binary file looks like in the root and how it really loads into the memory and how it works. The biggest thing is none of these which have been declared around 20 years ago has not changed much, and it's still relevant. The still 32-bit files are still relevant, and the 64-bit files are still the same. What the only difference what it makes is at the location 104, where it says 4C01, which is the machine architecture. 4C0B or 014B will be your 64-bit architecture. Apart from that, none of the sequences have changed. It's all still the same. So on the left hand side, I've just put a few list of terms which you need to know on the PE file format, which you need to read a lot on the PE file format. They are like the DOS stub, the reach header, the PE header, the optional header, the data directory, section header, sections with imports and IAT. Imports and IAT is a very big difference, and you need to understand them. So that's with the PE file format. So in the next slide, I'll be explaining about the Hello World program, the same Hello World program, but it's be going with the twist. Next slide, please. So here, what I'll be doing is I'll be writing the same Hello World program, which will be the compiler, the optimized one, which is the top one, which I already explained. So in that, what I'm doing a small change is I'm adding a volatile variable to it. So volatile int a is equal to 0 instead of your normal int. So I hope you would have read about in your school about the storage classes in C, which is static, int, external, and volatile. So this is a volatile example of what I'm explaining, which not many of the books would have explained here. So here what you can see is when I use volatile with compiler optimization, on the right hand side you can see that the code is pretty much the same. So what happens is the code of a is equal to 0 is not optimized. So in the first example you saw a was optimized to run from FF to 0 in a decrement order. But in the same program, what I am doing is I am saying it's a volatile variable. The variable what I have declared is volatile. So basically that variable will not be optimized. So that's the corresponding code notation. But on the above, what I have done is I am printing the value of a along with hello world. So what happens is even with compiler optimization, the value of a is not changed because the value of a has to be printed, and that's the reason why the value of a is not changed in the top one and the bottom one. It's because of the volatile variable. So that's the hello world program. What I've explained you here is very maybe a very basic level, but all you need to do is you need to experiment these things and you need to keep retrying this again and again. You need to understand where the win-main function for C is. Once you are able to navigate to the win-main function, and then you will be able to disassemble it, and then you'll be able to find out how your original C program got translated into a binary code, and then how you can reverse engineer from there to the original C program. That's the whole art about reverse engineering. And I think that's it from my side for the reverse engineering part. I'll just quickly jump into the dynamic analysis, which I have prepared a demo for. It's a demo video. Let me really run through this fast and try to make you understand the process of it. So what I'm doing here is I'm taking a malware from VirusTotal, which is a free web service, so you can register with your Gmail address or any of your personal ID addresses, and then you can start downloading malware. I think it has a download rate of like 20 files for 5 minutes or something like that. So it's easier for you to download a malware, or even what you can do is you can write your own, you can copy in your own compiled malware or anything which you have, and then you can do dynamic analysis of it. So the tool what I'm using here for dynamic analysis is Rexshot, and yeah, so when you can start playing the video now. So what I'm doing is I'm just executing Rexshot here, and I'm doing a configuration saying that scan all the directories starting from C drive and scan all the registry entries, and then I'm just taking a first shot. So what happens is Rexshot will take a snapshot of the whole file system and the whole registry hives what it does in a text file, like a database store. So it says file number 123 has been stored in C123 folder, and it has a creation time of so and so, it has a modified time of so and so. All those things get stored. So when you click on the first shot, what you see as enumerating here in the directory is the same. Then what I do is I'm just running a malware, so which is basically ransomware, which Deepak has previously explained. So when you execute that, you can start seeing visible changes. The reason why I took ransomware is because it does a lot of file and registry based activity, and it's really interesting to visually see and understand all the stuff. So here what you see is one example where the screen is your background wallpaper turns blue instead of your existing black one. So what happens is it changes the black one and says, I'm not sure the text is visible here. It says your system is encrypted. Go and read so and so file for more information. So when you open the text file now, maybe you can scroll it a bit forward. Yeah. a bit more, where the notepad is being opened. Yes, this one. So what happens is you can see a note in the background saying all your files are blocked and it can be lost. So find this specific file and folder, and otherwise your file will lost forever. So this is something which an example file which I downloaded from VirusTotal, and I'm just explaining it for you. So it has a specific key to it to identify, like how Deepak said, ransomware service, all those examples. How it works, affiliate ID, all those is the screenshot what you see there. So now what I'm doing is I'm just doing the second shot. So it gives me the delta from the first shot to the second shot, where in the first shot I ran it before running the malware, and the second shot I did after running the malware. So right shot gives me a delta of what changed from snapshot 1 to snapshot 2. And this text file, what you see here is really the changes between what files changed, what registry entries changed, what values were modified, what files were added or deleted, all those things comes in. So here what I'm highlighting here is the original image files or the backup files, whatever I had for my tutorial, like OE debugger folders, which had a .back extension, they got encrypted. So that's something which I have explained it to you. Once, so this is how you understand what a malware does dynamically. So for reverse engineering, when you execute a malware, you will understand what kind of file changes it has done and what kind of registry changes it has done. So when you do the reverse static disassembling part, you will understand what all are the interesting strings for you to search for, where to start for. So if I can see a lot of files being modified, the original program when I load it on OE debugger, it should have an import of create file or a open file or read file operation. So you can easily do a breakpoint on all these kind of APIs, and you can start debugging or understanding what really happens in the background. So that's the reason. That's how you do the whole reverse engineering part. To start with your dynamic analysis, understand what the malware does, and then use those pointers in static debugging, because static, what I showed you was a very small hello world program, but if you see the whole malware, it will be like pages and pages and pages of assembly code, and it's really hard for you to find. So these kind of pointers, what you find in the text file, will help you relate back to what kind of strings which is available in the code, and then you can start disassembling from that point. Or you can start, if you are really having a lot of time, you can start from entry point and go through function by function, which will again help you in the complete reverse engineering or reversing of a specific exe file. Here I've covered only exe file, so I'm just telling you it's just an exe file. And I think that's it from my side for dynamic analysis. So in the next slide, there are few places from where I learned reverse engineering, which is Lena's tutorial, which is really old and it's really still relevant today. It's really a fantastic one. Search in torrents or anywhere where you get these tutorials, and it's really good. I think there are a few in YouTube also. You can go through them. They are really good. Then the second book is about Windows internals, which is by Mark Rusnovich. So this really helps you understand how the Windows architecture is, what is a PE loader, when you execute a double click on exe, what really happens in the background, how Windows loads that executable, how it makes sure the memory is available across all the applications, all those kind of things will be done by Windows, will be explained in this book. And the third book is The Art of Reverse Engineering, which is really one of the Bible, which I would say, for reverse engineering. It's a really fantastic book. Just follow those books, but do keeping up the practice. That is something which you should not be ignoring. Don't keep practicing, and that's something which you need to. The fourth one is Practical Reverse Engineering by Bruce Bank. That's a very basic level, and it's a good one to start with again for reverse engineering. So I think with this slide we are at the end of our session, and then it's for you. I'll put up this for any further Q&A sessions.
Thank you, Senthil. We have a question and answer session now. I have posted all the questions in the WhatsApp group. You can read the question and answer one by one.
Okay, sure. So I'll read the question. So either Deepak or Sriram or myself will take it up. So the first question I see is what is PE? I think that has been explained already. PE is nothing but portable executable, the expansion of PE, and they are just any exe or DLL files. We just generally we call them as portable executables. So meaning they just run by double clicking. And I think Sriram also showed a screen where he explained the PE structure also. So that was one question. Second question, I think maybe Deepak, you can take this. Can you give some tips on how to protect my system from these attacks?
Yes. So what attacks? More. If I be more generic, it's on a single machine. If a person is looking at, I would say, then update the AV, use a proper AV, update it to the latest version, and keep it. I mean, if the users are talking about a single machine, a home computer to protect, and yeah, run regular scans. That would be the best way to protect against these attacks.
Yeah, I think an add-on is like, again, from a user perspective, you need to be very careful on the kind of links that you click on an email and the kind of websites that you normally visit, etc. So there are tools now available to check your website and tell whether the website you're visiting is good or bad. So try to have those tools installed on your browsers. And also, most importantly, many of these malware spreads through spam emails, which are nothing but junk emails which come into your inbox, but they look really true. And so we would be forced to go and read that spam email and click on some link, and that will be a very bad thing to do. So we should be careful before we click on any links in an email, because you click on a link and then it opens up a website and it can, without your knowledge, download some of the malwares from that website. So you need to be careful not to click on links on an email which has not come from a person you know about. And again, like keeping your AV updated and running scans and keeping your operating system updated is also important, because
Hello. Hello, Deepak.
I think we lost Central there. I'll try to cover it from there. So you need to keep up. What he was trying to tell is you need to keep the system updated, and you need to run scans even if it is your AV like McAfee, or even if it is Windows Defender, which comes by default, which is installed on the OS. So that's that question. Go to the third question, which is Monero considered as a cryptocurrency like Bitcoin? So Deepak, you want to answer that?
Sure. Yeah. So Monero is a cryptocurrency. It is similar to Bitcoin. Bitcoin, though, requires something called ASIC. That is application-specific integrated chips. I mean, it cannot be mined on a normal machine, on our laptops or on a desktop machines. It requires specific, hardware. Monero, on the other hand, can be mined on any other on any machine. That's why it's pretty famous with the malware writers. And also, when a transaction takes place, Bitcoins, every transaction is recorded. In Monero, it is not. So that's one of the reasons why Monero is very prevalent these days.
To add to that, Deepak's answer, Monero can be even mined with GPU, which gives an added more advantage. So when a person is able to infect a person's machine, he'll be able to mine currency not only from his CPU but also from GPU, and that's the reason why Monero is really a choice for the malware authors. So thanks for that, Deepak. Then the fourth question we have is, I have a question with reference to WannaCry kill switch. What is its purpose? Okay, WannaCry kill switch. It's kind of an advanced question. So what WannaCry kill switch is, basically when the author develops, what Deepak told was about affiliate IDs. So basically, you want to understand what the affiliate ID is. You need to understand the background of how ransomware as a service works. So once I can understand those kind of things, the affiliate IDs is something which you get into, and in that, so people want to go and test what kind of affiliate you got it from. So basically, there are a lot of bases, like some executable creates a registry key, some executable creates a file. So here in the case of WannaCry, it created a file, and that was the kill switch, which it was, and I think it is it's something which is there in your Windows DLL folder, and it was found by one of the reverse engineers. Basically, he understood how the WannaCry has been compiled, and he was able to get to this kill switch. And then, if we have created that file already in the system, it will not be infecting it. That's called a kill switch. So after understanding, so basically it's for identifying the escape ID to be exact. I hope that answers the question. And then the fifth question, is it malware can be spread through mail attachment? I think this has been covered previously. Yes, malware's main motive today, most of the top malware what you see on the ransomware evolution or on the slide what Deepak showed you are spread via attachments, mail attachments, and mail attachments can be of any extension. It can be like an Excel file, or it can be a Word or document, or it can be a PowerShell or a PowerPoint, or even an LNK file, or even an ELF binary. It can be any form. So yes, that's. Sixth question: can malware designed for Windows OS can also be used for Linux OS? Yes, that's a good question. What happens is currently we have not seen a variant like that where it can infect on both Windows and Linux OS at the same time. With the advanced commands of running Linux over Windows today, which is available, and the case sensitive file system, we do have advanced OSs, but we do have POCs which runs across both the architectures, but OS architectures, but we have not seen any wide variety of malware in the field infecting both Windows and Linux OS at the same time. Then the next question is, could you explain the steps for reverse engineering starting from the APK file for Android app to the code for the app? So I've not covered that. I've just covered a very basic reverse engineering of the C++ file. But reverse engineering of APK is something which you can do from the tool what I told you, which is next to jar. So basically, it will decompile the class files into your jar bytecode, jar commands, and you'll be able to understand those routines. So that's something which you can do. There are a lot of tutorials available, I think, which you can follow with. So that's with that question. So for learning reverse engineering, any prerequisites are there? Yeah, I'll answer that question. So for reverse engineering, the prerequisite is you need a compiler, what you want to learn for. I would say you start with learning one compiler at a time. So for example, the code what I showed was for C programs. So write a lot of C program, write a lot of loops, write a lot of, see how a while loop works, see how a for loop works, see how the different storage classes work. There are basically 32 instructions or commands you call in C, and start experimenting with all those things like size of or all other things. How intern works, how a register works. Try changing your probabilities. The more probabilities you change and the more reverse engineering you do, then you will understand how a code has been translated from C to ASM. And once you know that translation, the reverse is very easy for you. So whenever you go and see another bigger file, you can understand what kind of a compilation it is, and then going back to original code. So this is the same logic for any compiler you see, which is like Pascal, or if it is Android, or if it is for .NET, all these things. Both .NET and Android, there is a small difference because they work on virtual, they call the term virtual machine, and all it has is virtual bytecode. All instructions what you saw in C are like instructions which is getting executed at the processor, on the processor, or processor executes in a single cycle. But with virtualization like .NET and Java or APK files or Android, it's not the same, because for the platform compatibility, what they do is they have a virtual machine and they execute all these applications in a sandbox. And sandbox then translates your instructions into architecture-specific instructions and then executes it. For example, if you ask it to create a file, there will be a virtual linking to a specific location where you create that, and then it goes and handles that in specific instruction at the sandbox level, and then out of the sandbox and then create it on the file. So there's a specific next level step between the way how it executes in a C file and then how it executes in a virtual machine. So there's basically a difference there. So that again, to understand what kind of a instruction it is, you will need to still understand the virtual machine bytecode. It's called IL, intermediate language. I think there's a term. I'm not much familiar with the reversing of .NET and with other advancements, but there are a lot of steps in it. At the end of the day, they still translate into binary code, which is what I'm interested in. So I'm still at that level. I'm not at the virtual level, which is what I would say. So hope that answered the question. The next question. So for any software, if a malware is found, then do we need reverse engineering to get out of it? Is it true? And which tool is that? Okay, so here I would assume that in your scenario, you will have identified a system which is infected, and you identified the executable which is which has done that operation. So what happens? What you might want to do is you need to take that file out, which know that it is malware, and there are a lot of online services available like app.any.run, which executes malware at the backend, or there's something called Joe Sandbox, which executes any file. So you can upload your file which you found as malware to one of these sites and then understand the dynamic analysis part of it, where basically it says what files have changed and what registries have changed. Then you can go back to your system, undo those changes manually or using any of the tools like autoruns or system assistant tools for that, and then you can get restored back to your system after rebooting. So that's something which I'll recommend you to do. I think I hope I answered that question. So the next question is, in which area where volatile variables are used? Actually, volatile variables are mostly used in big or microcontroller level programming. That is basically, for example, if I want to loop through specific ports, and C compiler goes and optimizes that. And if I'm controlling a 7-segment display, I need if compiler goes and optimizes, then the display won't be available for a 7-segment display. So at that level, volatile variable is used, and that's an example what I have shown. Today, it's not used widely, at least in system level. If you still go back to your CCS compiler or any basic PIC level compilers, that variable is still used, and that's one example. The next question I will be reading out is, describe a tool that you can implement at the firewall level of a network, which would help you analyze malware threats.
This
Firewall.
I think in the future.
Sorry, I didn't hear that.
I think Sriram, I think in the future presentations we have with the NIPS team, they would help. They would explain these better, I guess.
Oh, perfect. Thanks for so stay tuned to the next presentation from SciSec and McAfee, and you should be able to see that. Thanks for that, Deepa. So the next question.
I think we can't hear Sriram.
What happened?
Abbas, you still there?
Yeah, I think I've got dropped off, Deepak. Sorry, I'm still there. Yeah.
Okay. Let me ask the next question. Junk files which are created. Some topics, research topics in cybersecurity. So let me answer that. Cybersecurity is pretty vast. So what Sriram and me spoke about is specific to files. You can do a lot of research on firewall, the network traffic. So if you're looking for files, the topics which Sriram suggested at the end of his presentation, that would be the best way to start off. And you could get a deep understanding of files, how it can be, how reversing works. So that's where I would start off if you want to understand, file-based cybersecurity, and where we specialize in the antivirus cybersecurity field. Moving on to the next, the junk files which are created in folders are also viruses. Well, junk files can be anything. Some of the junk files are basically files which can be used by the portable executable files. Like sometimes what happens is malware stores a key in a junk file. So the executable file can just read the key from the junk file to use it. On its own, it's not malicious. It can't do anything. But as a part of an attack, it can be used by a file to, it can be used by another file. So on its own, it's not malicious. Yes, in a bigger scale, yes, it can be used as an attack. Okay, the 14th question, can someone attack on IoT devices and how they modify files? I think, Shriram, this is something related to the IoT.
Yeah, I can cover that question. I can cover that question and quickly. And yes, IoT at the base architecture has been Linux currently, and we have a lot of different flavors of Linux for IoT, Raspberry Pi or any other kind of ARM architectures. And yes, at the end of the day, the network level or activities are still the same. Like SSH, how you log into a Linux machine is the same how you log into IoT device. So basically, it starts from what architecture you are targeting for, and then trying to attack it. You can, there's something called fingerprinting where you can verify a specific IP address and then try to understand what kind of OS it is, which is basically called fingerprinting again. And once you understand what OS it is by doing a port scan using Nmap or something, then you can open what kind of services you have. And then Nmap itself gives you a lot of fingerprinting for what services, like if it is OpenSSH Debian, then you can say it's a Debian-based Linux. Could be Ubuntu or it could be Debian. Based on those fingerprints, you can understand what OS it is, and basically you can start your attack on the IoT device. So that's normally the step what they do. You need to fingerprint what OS it is. That's how you start with. Not going into details. So let me stop here. Back to you, Deepak. The next question, what I can see is it necessary to have any extra antivirus or Windows Defender is enough? It's left to you. It all comes with the time and performance trade-off between the performance and your processing. So if you are okay with slow machine, but still you want to be very secure, then yes, you can go for multiple AVs. But really, I would say choose one and choose one which is really the best. So I'll start there. Next question, which I will read to the readers. Explain the importance of software updates with regard to malware. Yeah, so this is a very good question, and I will try to cover this from the malware, which we already covered, which is WannaCry. WannaCry, we know, has been using the blue keep. Sorry, not the blue keep. I think it's double pulsar attack. And Windows has released the patch in the month of in the previous month, and since most of the machines which got infected were not covered or patched for this vulnerability, and that's when the malware authors were able to author a POC for that specific vulnerability, and they were able to exploit into the custom machine. So the moment every patch Tuesday, which is the second Tuesday of every month, Windows releases set of patches. So it is always advised you patch it and keep your machine updated so that these kind of attacks which comes in via IP address or fingerprinting will be blocked. So that gives you the flexibility. The next question is, can you name any malware that launches DDoS attack? You can refer to Git, NDDoS, or Mirai for that. That's a good one to start with for understanding DDoS attacks. The next question is, are any AVs available for Linux? Yes, most of the vendors have AVs available for Linux, but most of them are command line level. They don't have a fantastic or a good UI, or a good looking UI like how you have for Windows. They are available for it, and slowly the malware industry or the security industry is moving towards securing Linux devices also. Yes. What about Pi cryptocurrency? I'm not going to answer that question.
Yeah, I think, Sriram, the Pi cryptocurrency is the one that can be mined using cell phones. But we have not seen any malwares related to it. at least in our field right now. That's all I know. But yes, I know it's one of the cryptocurrencies that were launched in 2019. But yeah, we've not seen any malwares related to the Pi cryptocurrency.
Okay. Okay. Got it. Okay. Thanks for the data. The next question is: Bitcoin is traceable while Monero is not, but why Bitcoin is so popular in the market? Maybe to answer that question, I have been part of the Bitcoin network from 2010 or 11 when it started, and I have been a part of it. I still remember mining cryptocurrency or mining Bitcoin from my Raspberry Pi at that time. So yes, since it's been a long time in the market, it is it is famous, but otherwise, I mean, add to that reason, there are a lot of places where you can buy and sell cryptocurrencies. There are a lot of exchanges for that. You can buy and sell cryptocurrencies. So that's another a reason why Bitcoin is more famous. So
There is
hope that answered the question.
yeah, there's one interesting question, like what Linux vulnerability is exploited by malware?
Okay, what Linux vulnerability? There's a CV called CV20192725, which is on which infects on Oracle WebLogic server recently, and we have seen CB malware, ransomware, which exploits these web servers and attack into the system. So that's one of the recent numbers what you can look out for. So CV20192725 and 2729. These are the ones which you need to look out for currently.
Yeah, so if a system has a problem during booting, what kind of malware could be there? Can you give some example?
System problem booting up, right?
Yeah.
Well, it totally depends. I mean, is it taking a lot of time to boot up, or the malwares which infect the boot sector usually do not, slow down the machine. They either block it or they show you a ransom message. So viruses these days are pretty less because of the way Microsoft has designed the kernel and the extra text they've added. So booting up slowly can be a lot of reasons. Maybe the machine itself is slow because of a lot of malware, a lot of software which are not supposed to be on it, like the pubs and stuff, can make it slow. So there is no one reason I can say that this is why the booting of the machine is slow. One thing I would check is to check the startup folder and check the run entries and see if a lot of software are starting up from there. And probably that would be the first step I would see. And remove and see if there are unwanted software starting up during the boot up. That would be.
Yeah, there's a question on can machine learning help in malware detection?
Shyam, you want to answer that because you've done a lot of work on machine learning?
Sure, yeah. So, yeah, machine learning, we have been trying to cover detect malware for using machine learning, where we delegate the job of identifying files of malware to a machine. We have been quite successful there, and we have been quite successful with specific type of compilers, and we would say, yes, machine learning is helping us a lot in trying to detect malwares which are unknown to us. And it's a good place to invest your future in, yes.
Yeah, I think maybe we have time to take one last question. I think we have covered most of them. So, Sriram, did you answer this question? Like, why was in the demo the malware was run on Windows 2K? Can it still have the same effect on modern Windows OS like Windows 10?
Okay, I pretty much I think I run the system as malware on Windows 7 machine, and it's still on the NT architecture. The reason why I didn't get the what to say, I think the OS is still the same even today in Windows 10. The only thing which changes is the case sensitivity of the OS. If that changes, things might change. But otherwise, most of the things what you saw on the demo is still going to be same across all Windows OSs, which starts from Windows XP to Windows 10 today. That includes Windows Server 2016 and 19 also.
Okay, thanks. So last question is, explain the importance of software updates with regard to malware. Yeah, I think
we covered that. I gave the example of WannaCry, and I've covered that.
Okay, I think we pretty much answered most of the questions, and we are run out of time. So Abbas, back to you.
Yes, thank you. Thank you, Sunil. Thank you, Sriram. Thank you, Senthil. And thank you, Deepak. It was a really good session from McAfee. Interestingly, I think we'll have 3 more interesting sessions in the next 3 days. And thanks a lot once more for having this session. Okay. For the audience, I'll be sharing the link of assessment in Q&A section, and we'll not be sending an email to all of them. The link will be accessible for 1 hour. It's 6:35 now, till 7:35 it is accessible. Please type the URL on the browser, and please answer the question by 7:35. Thank you. Thank you, Sunil, and the team. I think we can draw from the session. I think this link will be let it open for 1 hour, so that if the participants has any queries related to this link assessment and other things, I'll answer them. Okay. Hello.